Hi, it's Gadget UK here again. This time I am not sure what I'm looking at. This turned up sort of unexpectedly today, and it just said turbo graphics on it. So I was like, well, that's strange, I'm not expecting a turbo graphics. You know, I wonder if it's a repair or something. I think it is, but it's not the repair that it looks like it is. It's something totally different. I think this has come from a friend of mine, Scott, Console Snob, I think. We'll soon find out. That's just popped straight out. Final flight for the SNES. That is just fantastic. I'm blown away. Didn't have to send that at all. I offered to repair this for you, and it's worth pointing out before I start getting flooded with people trying to want repairs and things. I just took an exception to this, and I'll show you why. Because it's not a whole system; it's just a little bit of a system. This is where I believe the fault is going to be isolated to, and that's part of it. I don't really have time to be doing repairs for every single person who watches me on YouTube. You know, it's nice to get support from people, but I just can't. You know, with my health as it is, I just haven't got the time and energy and stuff. You know, I have a full-time job as well, and a family, you know, wife and pets and stuff to look after as well. I don't really have the time. That's the problem. But when it's things like this, small things, if you know, you can always ask me, and if I've got some time and it's something really small and I can fit it in, especially people who I do know, you know, who I've socialised with and stuff and met at play and things like that. It's not a problem. I'll squeeze it in somehow. Let's take this out of here. Let's see what we've got. But there's a lot of things in here. This is insane. Look at this. You know, sent me blazing lasers here for the turbo graphics. That's insane. Didn't have to do that, mate. I'm absolutely blown away. Seriously, I'm gonna. The value with it. I'm gonna have to pack some things in this when I send this back to you, which I will do. I'll get some stuff together and I'll send you some stuff. What's this? A pad? Gamepad? I don't even know what that is. Is that for Wii or something, or is it just a USB pad? That's brilliant though. Look at it. That's sweet. That is sweet. I think you've sent this to the wrong place, mate. You're supposed to be selling these or something. Send them somewhere else, because that's just awesome. And there's the wires for that controller as well. That's just brilliant. That's fantastic. Absolutely blown away. Again, brilliant. I don't know what to say. Fantastic. I'll get that on my Wii. I'll have a go at that later. Awesome, thank you very, very much. But this is what this is all about here. This box, this large box for this. So I'll just get this out of here carefully. You'll see it's a control board for Neo Geo CD. And I'm pretty convinced that, I could be wrong, you know, there is a chance it's not this. There is a chance there's something wrong with the Neo Geo, but I don't think so. I think it's going to work in a very similar way to the Neo Geo MVS and the AES. Because the architecture there is very, 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 very similar. From my understanding, I think there might be a little bit more RAM on the Neo Geo CD, but effectively it has the same architecture. You've got the same sort of, you know, sound slave system, if you like, there, where you've got the YM2610 or whatever it is, and a Z80 to control it. You know, on its own bus and stuff. CPU, the same sort of RAM and what have you. You know, it's all the architecture is very, very, very similar, but it's just the CD stuff, and I think there's some extra storage for maybe the sound or CD. You know, the CD buffer and stuff, and the interface there to the CD. And obviously, you've not got the complications around the cart side of things either. But because the architecture is very, very similar, if not identical in places, I suspect. Well, there's a couple of things. If you start looking at the control issue on this that he's got, and I guess it might be an idea just to rewind a bit and just explain what problem he's got. I think it was one direction. It was in one direction on a port that wasn't working. I can see a pin's being pushed out there. You know, you can see that's just bent a little bit. I can push that back. That's not a problem. But one port is not working properly. One button, one direction. I think one direction. It might be a button. I can't remember. I think it's down or something's not working. On both ports, and this is the interesting thing. You've got to then question, well, why would it be on both ports? Now, when I looked at my Neo Geo MVS and I had a control fault on that, I know that the Neo C1 handles the control input on there, and I think the way it did it in three reads, effectively, 3 different addresses that were mapped to the you know, the input ports. So it would read sort of, I think it would read like some of the directions for player 1 and player 2, and then it would read the other directions for player 1 and player 2 in the second pass, all using the same data bits, the same 8 bits each time, if you like, or the same 16 bits. initially you might think that maybe there's not a fault with one of those, and that could be the case. I need to do some checks and stuff on my meter and stuff with this, and I can power this board independently. I just need to find a contact to put a ground connection onto and a +5 volts, and then we should hopefully see the power LED light, and I should at that point be able to get my logic probe on there and start checking the inputs on here, just to see if we get any stuck highs or lows on both of these Neo Buff chips, so I can test if they're working correctly. I can connect my joystick up, move my joystick and trace basically where it's falling short, you know, where something's getting blocked. And I'm guessing if it's not one of these two chips, then it's going to be one of these two buffer chips here that fault. So it should be pretty straightforward. So I'm going to get my logic probe out, get a power supply, rig up the 5 volts and ground, and we'll take it from there. So I just found a letter here. I didn't realise this was in here. Hi Chris, here's the Neo Geo CD controller PCB for you to work your magic on. I have also dropped you some extra stuff in the box for you to tinker/play. Please enjoy your gifts. Thanks in advance, Scott. Fantastic, thank you very much, mate. You know, like I say, I'm blown away at the generosity of the stuff you've sent. The offer was stood there really to do this for nothing. I didn't expect anything. It's not going to take me too long to have a tinker with this, I don't think so. Let's hope we can fix it. So first things here, I'm just going to start with some basic checks. Got my multimeter on continuity, and I'm just going to have a look at that. I've just been having a look actually at the pins. You know, this port here particularly, I can see he's had to go resoldering this, and he's not done too bad of a job there. But I can see what, if you're not experienced, it might not be easy for other people to see. I can see like a micro crack across there where he's attempted to resolder that on, and I'm just not sure whether we've got a connection there. So before I do anything, like I say, I'm just going to test some basic continuity here, just to see if these pins are actually making a connection to the PCB or not. Well, they're going to make a connection with the solder point, definitely, but it's whether they're going all the way to the destinations, which I can check in a minute. So yeah, those first few pins there are looking okay, I think. That one's that one. Which one's that one? Yeah, okay, it's going to be... Yeah, okay. So, the next thing I'm going to do, if I just move the camera around a little bit, I'll try and zoom in. Sorry, it's not that easy to film this at the same time as do it. These top two pins here, I'm just going to trace these and see where they go. So, I mean, it comes all the way, this first one, comes all the way along here. I'm not sure if that's on camera, is it? If I just move this down that way a bit, it should be now. And we'll just see where it goes. It's going to be, where is it? That one, maybe. Yeah, maybe this is where the problem lies. I don't think that's making a connection. I think what we'll just do is just scrape a tiny bit of the solder mask off there, so that I can test that. Yeah, so I don't know if you can see that, but if I just scratch a little bit of that solder mask off there, we've got connectivity, but to the pin we don't have connectivity. I think this is going to be a really simple one, this. I mean, it could have been that that's been done as an attempt accidentally to try and resolve this problem. But we can test a little bit more thoroughly. I mean, if I put it back on the trace, it's okay. Put it on the pin, it isn't. So that is very interesting. So before I do anything else, I'm going to get my desolder pump onto there. Just my cheap jobber, you know, my 15 watt iron, and just desolder this, just clean it all up and have a look at it. Right, so we've got Super Macro on there now, and hopefully you should be able to see. Can you see that it's lifted? That pad is lifted and it's separated here from the trace. So even though it was soldered on the pin, it wasn't making a connection to this trace. That was certainly the problem there. So what we need to try and do is, you know, sort of, I don't know, is try and resolder that. But then I think I'm going to bridge it. I'm going to use a wire, put a wire around here and trace it to wherever it goes over here, so that should it come completely off again, that it will be okay. Obviously the pin needs pushing back in here as well, so that is a clue. You know, if you ever see anything like that, there at the back of a bunch of pins, that's a clue as to what's gone wrong here, that pin's been pushed with too much force, you know, it's got stuck or something, because they get stuck. See if I can just push that through with a bit of plastic. Yeah, there you go, it's gone back into position. And then on this side here, yeah, that's pushed through a little bit better. It's still a bit recessed, I don't know if you can see that. It's still recessed in there a little bit. So I'll use some pliers just to help pull that through a little bit. We'll test continuity. And then I think ultimately what I might do is use the glue gun here to yeah, I might have to improvise, but I might use the glue gun just to put some glue along the back side of there, just to stop that pin being easily pushed through. It should be supported by the other pins that are next to it and stuff. And it's easy to get that off if we ever needed to, you know, if we needed any work on it, doing on it again in future. I guess we could replace the whole socket here. They're not that easy to come by with the extended things there. But to be honest, there's nothing really wrong with this other than the fact that one pin that's got stuck and broken from the track there. So I need to clean this up with some flux and stuff as well, and obviously resolder that bottom pin because we've got two pins that aren't soldered at the moment. But I think once I've done all that, then I'll wire up some power and we'll test all the inputs just to make sure they're passing through correctly from you know, sort of start to end. I think just looking where the ribbon goes. Yes, the ribbon goes in there. We should be able to test some outputs, I guess, there and see make sure we've got you know, corresponding movements for each of the two ports on here, either with a logic probe or a multimeter or something. So what I need to do now is work out where the +5 and the ground is. Simple way really on something like this, or any system really, is if you inspect the board, and like down there we've got, you're not going to be able to see this because I'm going to have to just use this to zoom in a little bit, hang on. Yeah, we've got a 74174 there, standard 74 logic. So I think off memory the ground's going to be down here and your +5 is going to be up here, but I'll double check because I'm a bit rusty. And it's as simple as that, so I can trace, if that's the ground, I can trace around to some point maybe like that there, just solder a wire off there, that's my ground wire. Same thing with this, I could follow it to maybe there, it's a nice easy point to solder to, or I could follow it around, it's going to, I don't know, it goes all over the place this, I could just solder to another point that goes to there as my +5. I'm going to wire that up to a little socket, and then I've got a 5-volt power supply here, which I will plug in here. I need to obviously check the polarity, I don't want to get it around the wrong way. And then we should be good to go. We should at least get a power LED coming on there, and we should be able to get the logic probe onto the job. So there's my wire soldered on for my +5. Just a final check here for peace of mind. If you look at a cap, you've got a cap on the 5-volt line here, and this is another good check you can do. The negative is obviously on that side, so the negative is near the top side of the board here. On these two connections, so if I test from continuity to ground, that's correct. Across to the plus, nothing, that's correct. And it should be the inverse, that should be connected to the plus. There we go. So it's connected correctly there. I've double checked. It's on right with regards to the 74LS174, I think it is, and it's on correctly with respect to that smoothing cap that's over there as well. So there should be no risks in doing this. So I've had a quick look round. I don't see any particles of solder or anything on it. So we'll just connect the power and we'll just see what happens. If I just turn this upside down so you can see it, hopefully the power LED will come on. See that? So we've got power, so I'll just disconnect the power. Gonna go and get my logic probe and we'll get that onto the job. So I've got the negative probe of my logic probe connected there, and I'm just going to test that. You can never assume that surrounding large traces like that are +5. That could well be ground rather. That could be +5, but continuity wise there, yeah, it's showing us dead short. So that's okay for that. And obviously I've connected my other probe, the positive of the logic probe, onto my +5. So we are ready to have a look with this. I just need to make sure I don't pull the wires too much, because the last thing I want to do is short my +5 and ground and cause my fuse and my power supply to pop. Right, so here's the Neo buff pinout. As you can see, see if I can get something to point with. You've got a load of these, and don't mistake these for address lines, where you've got like A0, A1, A2, A3, blah blah, and then you've got B0, B1, B2, B3, all the way around. I think, hang on, let's have a look. B0A. Yeah, so you've got 16 A's and 16 B's by the looks of things. Is it 16? Am I miscounting? I can't see the bloody 16. Yeah, they are up here, the 16s. Yeah, you've got A13, A14, A15. So, hang on. So you've got 16, you know, it starts at 0. You've got 16 bits, 16 channels, and it's basically a case of somewhere here, I can't see the damn thing now, it's that direction and output enable. The combination of setting these pins to the right values, probably the direction one, that toggling between high and low, determines whether data passes from A to B or B to A, and when it's not, or it's the output enable's not on, you'll get nothing, you know, it won't read anything from there. So, and there's one of the, is there one of those each? Yeah, just looking, there's one of those on each side. You've got a direction pin on each side and an OE on each side. Anyway, in any case, I've now got enough here to follow the pin, you know, the inputs. If you look at the board, just follow the inputs where they're coming in here. Work out, according to this diagram, where each of them are going on here, and then determine where the output pin is on the other side. And let's just check to see what we get. Yeah, so I've got it all wired up now, and you'll see if I put that on the first input, the one that was broken off, press up, you can see the bit state change there on the actual input. That's how it works. It's highest default. When you press a button or a switch, it will go low. That's the way the controller works, and obviously it's only doing it when you go up. That's correct. So we've got connection there, and then the first 4 pins here are the first 4 buttons or directions, I think, on that port. So yeah, so you press left, was it right, so we've got activity, left, we got activity, up, down is that one, and then the 4th one, which is a 0, I think. Let's try that, up, so up's working. So we know that the input, you know, the toggling state there is working with regards to the wiring between the connection, you know, where you plug your joystick in, and this chip here. So the next thing we need to do is work out whether we get anything coming out the other side. So if we have a look at these 3 pins at the bottom right here, these are B0, B1, B2. As you can see, move the directions, buttons and things, nothing. Go to the next pin, B1, nothing. These are like high impedance at this stage, I think, and the 3rd pin, nothing. The 4th one, I think, has got a low on it, which is a different pin. Let's see what that is. Let me have a look at the diagram. That 4th one is the direction pin. Yeah, so I think if we made the direction pin high, the state will change there. I think might not do. We might need to make the output enable high, actually, now I think about it. Or bring it active low. Looks like it's active low, actually. So let's just check where the output enable pin is. That's the one next to the direction. So as we go along here, we've got nothing, 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 low, high, high. So it looks like we've got high output enable, I think, if I'm counting pins correctly here. Now what I could do is temporarily break that track. I could lift the pin. I prefer to break the track, I think, actually. Might be able to take a component out there, because it looks like it goes up to a component up here, whatever that is. Let's just have a quick look on that side there. It's a wire link, so I can remove that wire link, and that should mean that that output enable is open circuit, it's high impedance. At that point I can connect it to ground, and we should hopefully see some difference in behaviour. Right, so here's a brief update. It's been really fiddly, this, and I've had no choice but to lift the output enable pin, which you can probably just about see just down there. So it's dead straight. I've bent it really straight upwards. No damage. Should be easy to put that back. Now, if let's just test the logic probe, so you can see we've got nothing going on there. You know, it's working. It's showing high impedance. This is where it gets difficult, because I've got stuff all over the place, wires everywhere, and I'm trying to show you this on the camera as well. I'll just try and point the camera down a bit, and you might be able to see what's going on. So these first 3 pins at the bottom corner here, these are the outputs on the B channel. So if I put it on the first pin, I don't know, you can just about see that. Can you see that's a high? It's really not easy to do. Let me just move the camera. Now, if I stick on the first pin, you can see that's a high. Press direction, which way is it? Up. So that's the up direction. So the output is passing through that chip correctly. Now this is where it gets a bit fiddly, because I've got to try and do it without shorting them all. That's left. So the next one, oh god, this is going to be hard. The next one's the 3rd one along, which is right. You're probably not going to be able to see this, because this is, you see that? Just about. 4th one, which is very close to the chip select. is, I think that's direction, actually the direction, that's correct. Let me just look back at my diagram again. Where's my phone gone? Right, so that was B0123. So we had 3 directions working. The next one's now in this direction here. Again, I'm not sure if you can see this because of the way the camera is. So this is like B3, I think. We've done B0, B1, B2. This is B3. So that's like right, that's working. The next one is going to be a button, I think, probably. A, you know, you saw that there. Next one, B, C. Next one, yeah, so we've got C. I'm not sure what D is. Let's just look at the diagram again. So here's the other test you can do on these boards. They go straight through to the output here. If I just go, come back to this first pin here. See, it's a high. I'll move the direction. I'm moving left. See what I mean? So you've got a bit straight away going straight to the bus that goes to the Neo. That's right. The directions don't do anything, just right. So you've got left and right. If we just step our way around these now, down. What's that button? Perhaps, yeah. A. So we got A. So I'm not sure what. Let's have a look. I've got to try and do this without shorting these out. It probably won't make much difference if I do, but I don't want to short anything. Yeah, up. What's that one? B. So here's the update as far as I can do on this video, really. I've cleaned it up. You'll notice, you may or may not notice actually, I've reflowed both of these quad flat packs. Sorry, memory melted there for a minute. Both of these quad flat packs, so we've got some good connections on both of those chips. I've tested the 7406 LS06, 74LS06, no problems there. Had the logic probe on the 74LS174. Can't really see any issues with that, and to be honest, looking at the schematics, I've got them here. I'll show you just a bit of the one that's printed off here. It connects straight to, it's only the bloody page actually, it connects straight to the data, well, not only the data but the bus going to the sorry, excuse me, Neo CD itself. They come up here and they go straight to that connector. That's probably on the more modern one where it's split into separate connectors, but nevertheless there's no, you know, that's the only input into the 74LS174. The outputs all go to the NOT gates, as you can see, through these resistors. Tested all those 6 resistors, tested all 6 of those gates, and they just go straight out to the controllers. Now, and this is where I'm a bit perplexed. I'm not really sure what this output stuff is all about, unless this is, I don't think it is, because I was going to say the supply, you've got a VCC going to the controller ports as well, so some sort of output stuff going on that was perhaps never implemented in the controllers. No idea, maybe for force feedback or something like that, but I don't think that, well, you know, my understanding of the way the Neo CD controller works, it's very basic. It's just, you know, all you're doing is toggling, as you've seen with the logic probe, between high and low states. So not really sure what this output stuff is here, but regardless of, you know, that's not going to affect what the problem we're getting. I think Scott was saying it was the up direction. Well, I previously showed there when I which one was it? I was doing some tests on this chip here on the A gate, well, not really the A gate, but the A side of it, and all of the directions and buttons and things were working there. Now, it took me a while to work out what the hell was going on. I assumed this one would be for this port. It isn't. So I temporarily had to break a trace there in order to cut the chip select. I didn't want to lift the pin. It was easy on that side, but I thought I don't really want to risk it again. So I just cut a trace, and that's why we've got this wire here. It is joined back up again. I didn't need to put a wire there, but I just want to make sure that it's definitely not going to become disconnected or something when he connects it back up. So that's like a safety net, really. It's just an additional wire. You can see the pin went down on the other side. Okay, there's no damage there. And again, totally reflowed all 4 sides of that quad flat pack as well. But anyway, the point I was trying to make is the inputs for this port here, like the up direction on the second player port, goes through this chip again. I think it comes in, let me think, it comes in on one of these top pins here, something like the 4th or 5th from the top right, and it comes out on the same position sort of at the bottom. So I think it's like, you know, it's pretty much straight through, and I tested that and that works. So you can do up down, and you can see up down there. You put your probe on here, just like when I did the first port, you see up down going high and low, on here. So this leaves me now with a bit of a dilemma. I mean, I've done a few other things here. As I say, I cleaned this up, reflowed both quad flat packs anyway, resoldered the port there, put the fixed wire on it, resoldered the ribbon connector here, just in case there's some crap or something just on, you know, on the oxidization. Sometimes just heating, reflowing the pins there with fresh solder, sometimes on connections like that can make them start working again. So I'm sort of torn a little bit here. I can understand why that port wasn't working. It's totally logical because the trace was cracked. There's no way that first port was going to work with the up direction. But what about the second port? Now, I watched one of Scott's videos and I'm sure he had the control on the second port, and it started player 2 when he was playing Burning Fight there, and he still didn't have the up direction. So this is not as straightforward as had been suggested by on the Neo Geo forum, because I did post at the time when Scott had this issue, and they were saying, oh, it's going to be something on this board, it's going to be one of these Neo buff chips that's perhaps you know, pulling the line low, but I've proved that it's not. You know, I've tested this, let's say, step by step, and I can see that the signals are getting through here for the up direction and through to here. Now this is connected in parallel, but it's not like constantly pulling it low or pulling it high. It's just not. I've seen, you know, I've got evidence of that. It's just not doing it. I think the other inputs, we'll look at the D button. I think the D button goes through here, and I think some of the start and select go through here as well as the jumpers. That's what you got these for here. Those are detected by this. So yeah, it's like I say, a bit of a dilemma. You know, I fixed one thing, but I can't. There's nothing else actually wrong with this. So I am wondering if there's a fault on his motherboard. If there is, you know, it's pretty much game over, unless you can find another Neo CD that's faulty for spares. You know, I mean, there's a chance this might work. Something else I'll mention as well while I was here is on that when I reflowed this, there was a ton of like brown crap stuck on the top, like flux within the top 4 pins there. Was that anything to do with it? I don't know. I doubt it. But having put fresh flux on this and reflowed it, that's now obviously cleaned up and gone. So I mean, I'd like to hope that if I send this back, he might just find it works. But it's not conclusive enough for me. You know, that there is conclusive. That was conclusive. There's no way that port was going to work. But then, why didn't it work when he had a controller in the second port and he started two-player? You know, the player 2. I think it was. I'm pretty sure when he was playing Burning Fight, he said player 2 up the top right on the screen there, which suggests there's something wrong with the right-hand side as well. Now I don't know if you can see the pins are pushed in a little bit there. You know, that bottom right pin is just a little bit bent or not straight. And it's the same with that one. Even though I've pulled it through a bit, it's still not perfectly all the way through. So I can't help but wonder if maybe his controller's done this. It's got a controller where, for whatever reason, it's bent that pin, and then it's damaged. It's not only damaged it here. Maybe it's damaged it in his controllers, and then he's plugging his controllers in, and it's kind of both. You know, it's both problems. And when you plug it into this port, it's the controller that's the issue. When you plug it into that port, it was actually the port that was the issue. I honestly don't know. So I mean, I'll send Scott a couple of messages about this and see what he wants to do. Just see if I can move that pin a little bit. I mean, I have had the ports, the controller, in and out of here. I'll show you if I can find the damn thing. If I just get the controller now, you know, plug it in. That fits okay, you know, it's not too tight, it doesn't feel like it's catching or anything. The port looks okay. Let's just try that one again. I will stick some hot glue, as I said I would, at the back of this. You know, you see the pin's not moved, so it's not like it's getting stuck or there's resistance or anything. I think that's okay now. But yeah, so there is this chance there's something wrong with this console. Maybe it's the ribbon. You know, the ribbon. It's worth. I would suggest when he gets this back, it's worth having inspect the ribbon, look at the side with little metal shiny pins that are going to marry up with the thing inside there. Just make sure they're not bent. You know, sometimes they bend up. Individual ones of them bend off the thin plastic. You know, flexible cable thing there. It's worth it making sure they're totally flat. They're all flat. none of them are damaged, and then just reconnect it, disconnect at the motherboard side as well, and just reconnect at the motherboard side, just to make sure everything is properly connected there. And then I guess you're just going to have to retry it. If there is a problem, it's still not working, then we're looking at a fault where this connects, where it's reading, because I mean, you've seen yourself there with the Logic Pro, probing a pin here, you can up down on the joystick, just up release, and you can see it go low, high, high low, high low, high low. So my work is done here. I hope that this works. I hope he's not looking for a new system. Anyway, thanks for watching. I'll see you soon.